OK, so let's get going. So my name is Dmitry Jemerov, and I lead the tools team part of the Kotlin team. So my team works on various IDE plugins for IntelliJ, Eclipse, and NetBeans, and also on build tools, including Gradle, Maven, and Ant. And that's what I'm going to talk to you about. And I must actually be a really brave guy, because not only did I sign up to do all the demos during the keynote, but I also have my own talk full of demos. So, well, my trusty cell phone is with me. Hopefully, I will not need it. So the first thing I will talk about is multi-platform projects. So Andre gave a basic introduction into what this is and what this is all about during the keynote, but he didn't really have any time to go into the details. So the details is basically what I'm going to talk about now. So as we talked about already, so a multi-platform project contains modules of two kinds. There are common modules, and there are platform-specific modules. So the common modules contain only Kotlin source code. You are not able to compile any other, like Java code or JavaScript code, into a non-native platform. And the platform-specific modules can contain like code in other languages. So for example, a Kotlin JVM module can contain Java source files. And when you compile that, so basically the Kotlin compiler takes together the common source code and the Java-specific source code and produces a bunch of class files, which you can then pack into a jar file or transform into an APK or whatever you need for the use case that you have. The same happens with JavaScript. So we take the common code and combine it with the JavaScript-specific code and produce a bunch of JS files, which can, of course, reference JS libraries and other stuff which is native to the JavaScript platform. Note that you cannot compile common code by itself, because there is no target to which it can be compiled. It can be compiled to any target together with the corresponding platform-specific code, but by itself, it's just declarations. It doesn't make any sense. And this will become important when we start talking about libraries. So once again, this is this expect actual example that Andre was showing. So this is part of the KotlinConf app. We have built this common abstraction for dates. And what's new here compared to what was shown on the keynote is that this actually shows how the actual and expect declarations are matched with each other. And the answer to that is they have the same fully qualified name. So an expect declaration has simply the same package as the actual declaration. So the common code expects there to be a kotlin.date.date class. And the platform-specific code defines that class. So kotlin.date.date, in one case, it's a class for Kotlin JVM using Java APIs. In the other case, it's a JavaScript class. But they all have the same fully qualified name. And of course, the IDE takes care of all the things that you need to use when you have like this structure, so that it's all consistently linked together, and refactoring take care of that. And once again, I'm going to show this later when we get to that. So why did we not just go with interfaces? Why did we come up with all this expect actual thing, which seems on the first glance it seems a little bit more complicated? The answer to that is that it gives us much more flexibility in terms of the kind of APIs that you can provide. So it's not restricted to classes. You can provide an expected. You can say that the common code expects a top-level function to be there. You can say that the common code expects an extension function to be there. And when you, for example, if you think about the coroutine, how coroutine APIs are used, it's all like being able to call top-level functions is essential for this. And so, of course, we want to enable this in cross-platform projects as well. And one other nice advantage is that you don't have to come up with ways to create instances of those interfaces, so you don't have these factories or dependency injection or some other mechanism that will actually let common code get hold of instances of these platform-specific things. So you can just define a class expected top-level function or an expected class that has a constructor, and you will be able to call that constructor from common code. And this all fits together really nicely. And of course, so yeah, this is just a very simple example of common code using an expected declaration. It's not different in any way from just regular Kotlin code. You have a date class, you are using the date class, and this gets compiled to whatever you need on the specific platform. One other advantage of this expect actual mechanism that we have is that an actual declaration does not need to be a class that you develop from scratch. So it's a very common situation that you already have a Java library that provides the API that you need, and you want to be able to use that library in common code. So in this case, the library that I'm talking about is JUnit. So JUnit already defines a bunch of annotations that lets you mark some code as tests. And we don't want to reinvent that. It works perfectly fine for us, but it's not available on the JavaScript platform. So what we do here is we define an expected annotation kotlin.test.annotations.test. And on the JVM platform, it's implemented not by a class, but by a type alias. So instead of writing our own implementation, we just point to an existing class and says that when someone asks for this test annotation, just give them an instance of .junit.test. And on the other platform where you don't have this class defined, you just write your own implementation. So instead of just creating your own, coming up with your own abstraction and providing two implementations, you just take an existing implementation, extract a facade out of it, and then provide another implementation of this facade on the other platform. So this saves a lot of work in many situations. This shows how you compile a common project, so like a common module in a multi-platform project. So this time we only support Gradle as the build system for multi-platform projects, but we're probably going to extend this to Maven and IntelliJ build system as well. And in a common project, you can have dependencies on other common libraries. So in this case, the common library that we depend on is the Kotlin standard library. There are also a bunch of libraries that we built, such as the serialization library, the testing support library, and we hope that there will be many more common libraries coming out later when the community starts playing with this thing. And of course, we are building more of our common libraries as well, as Andrew mentioned during the keynote. So there is a separate plugin that lets you build a common module, and there is another different type of plugin that lets you build a JVM module, and there's also one for JavaScript. And the way you link the modules together, the common one and the platform-specific one, is using this expected by dependency scope. So the common module is just there, defines the declarations, and the platform-specific modules are attached to it using this mechanism. So they specify, OK, so this module expects some declarations, and I have those declarations. And this is represented as a special dependency scope in Gradle. So yeah, this shows an example of a multi-platform test. So we have this Kotlin.test library, which has annotations and assertion methods. So it's nothing fancy, but it's just the essentials that you need to be able to write tests. And this talks about, so this is how you actually compile a common library. So when you compile a common library, you do actually need to produce some kind of artifact that represents the common code, not platform-specific. And the way we handle that is that the Kotlin compiler produces just the metadata. So it essentially contains the declarations, like what methods are there in this library. And this information is enough to build common code that links against this library. So in common code, you know that those declarations are there, that they are available, and you can refer to them. But in order to provide an actual code for a platform, then you need to have two artifacts. You need to have the common library, which the common module depends on, and you also have to need the platform-specific library that the platform module depends on. So essentially, every time you build a common library, you release n+1 artifacts, where n is the number of platforms you support. So like common, JavaScript, and like Java. And before we get to the next part, let me try to show you a demo. So where is it? So yeah, the first thing I'm going to show is how you can create a multi-platform project in the IDE. So you just go to create new project, and under Kotlin you can wait, what? You can select this category, Kotlin Multiplatform Experimental. And if you do that, just specify some name. Let me get into presentation mode so that you can see something. And here you have a project which contains of 3 modules. There is the common one with the Kotlin source directory, and there are also JavaScript and JVM specific ones. And the plugin by default configures all the wiring that you need, so all these like platform plugins, all the common library dependencies, and basically everything that you need to get started. So now let's switch to another project which already contains some demos that I have prepared for you. And this basically just contains the date code from the KotlinConf application. So first of all, yeah, one of the things I wanted to show you is that, let me exit the presentation mode quickly so you can see the tabs. So you probably can see that this JS date and the JVM date tabs have different colors. And this is just a very handy trick to use in multi-platform projects. You can go to the IDE settings, to the file colors, page, and define the colors for the scopes related to each platform. So this will be automated in the future, and we will also publish instructions how to configure this manually. But yeah, this is just a handy tip that will also make it easier to understand what's going on here if I was not using presentation mode, which hides the tabs. So now let's run something. So I have a basic main function written here. And this is part of the common code, and now I'm going to run it as a Java application. So it builds the project, and it will run this just under the JVM. It is possible to make it it is possible to support running the, like simple main command line functions under Node.js as well, but this is coming in the future. Right now, it's not available. Now let's look at the more interesting story. Let's look at the tests. So here I have some tests. A very simple test using this assertion library. Yeah, you've seen it on the screenshot already. And when you right-click it, you actually get the choice of, no, wait, I need to delete the existing run configuration first. Yeah, there are still some rough edges in this unit testing integration. So by the way, the functionality that I'm demoing it right now will not work with the released 1.2 plugin. This will work in the next update it will release because, of course, we want to show the latest and greatest stuff. This is very much work in progress, and like not all the progress is being released right now. So let me try this again. So there is this date test, and I'm going to right-click it, and I actually have the option of running it either as JUnit or under Mocha. So I'll run with JUnit first, and you see that I have a passing test with JUnit. And this was run under library Java virtual machines, all that stuff. Now I'm going to delete the run configuration again. And run it again. And in this case, I'm going to select the Mocha option. And now it runs the same test under Node using Mocha and using some other stuff that is required to have Mocha test running. Now, having this working requires some additional configuration, so you have to be running IntelliJ Ultimate. You have to have the Node.js plugin installed. It's not included out of the box, but you can install it once you have IntelliJ Ultimate. It's there in the plugin manager. Node.js, there it is. You also need to do some, like, not very obvious setup. You have to create a package.json file specifying a dependency on Mocha. This one. And you also have to do some extra magic in the build.gradle file, but we will publish a tutorial explaining how to get this working, so don't worry, we will tell you how to do this in your own projects. So of course I'm demoing tools, so of course there is assistance to help build and refactor multi-platform code. So for example, you can, if you define a new expected function, the IDE will help me to create actual implementations for the platforms for which this is missing. So in this case, this is JVM. And I can use like system.out.println because this is Java code. And also I can create a JS implementation, in which case I can use something like console.log in order to provide this, in order to implement this. And refactorings work across the cross-platform module boundaries as well. So for example, if I rename this method, so this rename affects both the platform and both the expected and the platform declarations. And if I add a parameter, if I invoke the change signature refactoring to add a parameter, just add a string called name. The actual implementations are also updated at the same time. So you can work with this mechanism to create abstractions even without losing any of the IDE support that you need. So that's what I wanted to show you regarding multi-platform projects, and I think it's a good place to stop and ask you for questions. So are there any questions on the multi-platform stuff, like what we are doing, why we are doing, like how this works, anything like that? Just, yeah.
So, how is cross-platform serialization going? Let's say I have a Kotlin class and Kotlin common, and I'm defining a server in Java, and I'm also defining a client in JavaScript. And so, can I take that same model, the Kotlin class model that I defined in Kotlin common, and ship it from JavaScript over to the JVM side, maybe from
yes,
servlet?
yes. Yeah, so the answer was, how do you do cross-platform serialization? And I can actually show how this is done in the KotlinConf app. So the data model classes in the app are there. So they all marked with the serializable annotation. And the serializable annotation is part of the Kotlin X.serialization library that we are working with. So this is a separate library. It's not part of the Kotlin standard library, and it's very much work in progress right now. So the current version is 0.2, but it's there on GitHub. You can look at it. There is some documentation, and yeah, you can just play with it. This is supported both on the JVM and on the JavaScript side. The serialization formats that it supports, it includes JSON, so I'll just show where it lives. Or not. Yeah, so the Wi-Fi is not really working. So I'll just go switch to back to the demo then. So once you have this, you can for example, look at how the web client does that. So here I'm using this JSON support from this Kotlin X.serialization library, and I'm using that to parse the data that is sent from the server. And this includes a compiler plugin, so it does some code generation to support the serialization scenario. And yeah, so JSON is not the only supported format. We also support protobuf, and I think some other formats that I'm not entirely sure about. And this is, in any case, the format support is pluggable, and you can add more stuff to it. Yep.
So can I put some code inside the shared module, shared part of that? So obviously it should be cross-platform.
Of course you can. So for example, like this, like in the conference app, since I have it open right now, I'm just going to show the complete version of it. For example, here we have some date formatting logic. So this is used to format the dates that you see on the screen in the web interface and on the mobile interfaces. And this is compiled completely cross-platform code that uses the date class that I have defined and uses the platform-specific implementations of those classes. And then this code gets compiled to Java bytecode, gets compiled to JavaScript, does not yet get compiled to iOS because iOS support is not yet part of our multi-platform story, but we are working on that. We have a prototype already. We are just not releasing it because it's very, very much unfinished yet. Yep.
What challenges do you still have to cover for the native stuff?
what challenges do we have to cover for the native stuff? It's nothing major. It's just build system integration primarily. So there are completely no fundamental issues that prevent this from working on native. And also in the future, we want to build, so this is not really a subject for my talk, but I just want to can mention this, I guess. So we also want to build so we are building a cross-platform HTTP client and server library. So as part of Ktor, there's also an HTTP client, and you will be able to essentially write the code that accesses the service also just once, and compile it to JavaScript for the web browser and to Java bytecode for the Android client and to native code for the iOS client. And of course, we also want to build an RPC-like thing in the future, but this is just too early to make any specific promises on that. Any more questions? Yep.
If I understood you right, you're compiling the common JavaScript files into a jar file. How do you picture those being distributed so that people can share multi-platform projects?
So the question is, how do we compile shared JavaScript code? So right now, we only support Gradle as the build system for multi-platform projects. So if you want to so the client of that library has also to be built using Gradle and the Kotlin Gradle toolchain. We need to have a story for building a cross-platform library that is distributed as plain JavaScript that like non-Kotlin developers can use. We don't have this story yet, but this will come in the future. More questions? Yep.
Are you expecting this kind of expect to replace J9 style data declarations? Can I bind to some arbitrary C code I've written with this? Like I have a C code base and I want to get colon, can I replace my J9 code?
So the question is, do we expect to be able to replace JNI with those expect actual declarations? And the answer is, I consider this somewhat unlikely. So we want to have a much smoother Java to native interop story than JNI. We have like all the pieces that we need to build that. But we don't have any specific design for this yet, and it probably will not be as smooth as just defining an expect interface directly pointing to an implementation native code. Okay, so let's move on to some other things, and now it becomes the tricky part. No, it's not yet the tricky part. So some other things that I wanted to mention today. So first of all, like Google announced their style guide, and we have our own style guide draft too. So this is still, we did not unfortunately reconcile them, we did not unfortunately have the time to reconcile them, but I expect that this will mostly contain similar things or like intersecting things. So I've seen some drafts of their stuff, and it was fairly similar to what we have. So the point is that we do want to have our own consistent style guide for Kotlin code, covering not only formatting, but also stuff like how do you pick which Kotlin idioms to use in which cases, when to use which standard library functions. So for example, we have this set of apply with also run let functions, and they are so similar that they can replace each other in many cases. And so people are asking, when do I use which? And we have some answers in this document. Please leave us feedback, especially please leave us feedback about things that are not covered that you think should be covered by this document. So this actually points to GitHub, and there's basically a branch on which you can comment, or you can just, I don't know. There's a coding conventions channel in our Slack, and you can discuss this stuff there as well. And of course, we want this to be fully supported by tooling, so we will change the formatter in IntelliJ so that it formats the code exactly according to the style guide. Right now, it's missing some of the settings, and it's not smart enough to do it with all that we want it to do, but we are working on that. A related thing is that we now have an inspection that highlights incorrectly formatted code. So for example, the style guide says that you should format else blocks this way without a line break. And I have used the line break here, so it highlights that please don't do that. And of course, there is a quick fix that just formats the entire file according to the code style. This inspection is available in 1.1.50 in the already released version. It's off by default, but you can enable it in the inspection settings. Maybe this will not work. So it's inspections, yes, and then, yeah, this one. File is not formatted according to the project settings. Another thing that we have here to help enforce consistent coding style are the inspections regarding naming conventions. So we have a whole category of them, so you can specify naming conventions for classes, functions, enums, and so on and so forth. We would prefer if you did not change the defaults, but if you really want to, you can do that. So you can have a different code style in your project compared to what everyone else is doing. But well, it's your project, so it's your choice. So yes, they are actually enabled by default. And so the next thing that I wanted to show, yeah, and we also have a bunch of other tools that let you that help you convert Kotlin code into some more idiomatic stuff. So for example, here I have a perfectly fine for loop that compared to what, like, if you were writing Java 6, this is what you would do. You have a collection of things. You need to find the thing that you need. You just loop through it. And Kotlin detects that maybe this is not the optimal way to do it when you have like functional programming patterns available to you, and it offers you a quick fix, just replace with any. And so this code just immediately gets converted into a much shorter expression. And this can actually handle fairly tricky things. It can detect nested code. It can also offer this replacement when there is when you need to perform multiple nested operations. So yeah, it's very nice. And one other example that I wanted to show about the power of inspections. So I have this code that's like, this looks something like you could write in Java. So you have a thing, you are doing multiple if checks to make sure that essentially categorize it to make understand which is which. And you could write this code in Java, you could paste this into a Kotlin file, the converter will automatically convert it and produce something like looking like exactly that. And what you can do now is you can use a series of inspections to transform this into something more idiomatic. So first of all, you replace if with when. It's already shorter. Now you can note that each of the branches has its return statement, and this is actually duplicated, and of course in Kotlin when is an expression, so you can just pull it out. Just do this, leave return out of when, and so now it's return when. And of course you know that if you have a function that has a single return expression in its body, then it's just an expression body, and you can make it even shorter. Convert to expression body. And the inspection helpfully highlights the type for you because the type is no longer necessary. You can just remove it because it can be inferred by the compiler. So just by applying a series of inspections, you have converted like a not particularly idiomatic Java code into something quite nice. And there is a whole bunch of inspections. We are adding new ones constantly. And by the way, here's the place where I want to really thank the contributors to Kotlin, because a lot of the inspections that are being added into new versions of the plugin are actually not built by people inside JetBrains, but by people who just like send us pull requests. And if you want to contribute to Kotlin, writing an inspection is a fairly easy place to start. You don't have to dive into the guts of the compiler, and there's plenty of examples that show you how this can be done. And if you are more curious how you can do this, there is one of our contributors is giving a talk on this, I believe tomorrow, how to contribute, and just go there and he will tell his story about this. One other thing that I wanted to show you is this. So like this style thing that applies not just to, where was that? Yeah, so okay, so I'll skip this part. So one more thing that I wanted to show you, if I go back to this color demo class, so you see these like arrows that like represent, like this is like standard Kotlin syntax, like you use an arrow in a when or in a lambda. Now I show you a magic trick to make these look nicer. This is not entirely Kotlin related, this is just basic IntelliJ functionality. So I'm going to go to the font style, select the Fira code font, and why was it? It's enabled actually. Why is it applied? Because I'm in presentation mode. So if I'm going to, yeah, this is tricky. So I'm going to exit the presentation mode now. And now my window is disappeared and it still doesn't quite work. Okay, so for some reason I'm not able to show this right now, but anyway, so there's this Sphero code font and enable font ligatures, and with this, like, the arrows look much nicer, just you have to believe me, because for some reason I'm not able to show it right now. So back to presentation mode. Two other related things that I wanted to highlight. So first of all, there's this semantic highlighting feature. So in the code style so in the highlighting settings, you can, if you choose the language defaults option, there is this semantic highlighting category, and you can enable this option. And what this does is that it gives a distinct color to each identifier that is available in a particular scope. So in this case, I have, if I go to, I don't know, here, or right here. For example, here I have from and to, the two different variables. And now this feature automatically assigns distinct colors for them, and so it's very easy to see which is which and how you deal with that. One other thing that you see here, which is enabled right now, it's not enabled by default, is this display of inferred types. So even though the Kotlin compiler has type inference, it's not in 100% cases clear what type is being inferred in each particular situation, and IDE has a feature to show you that. This is this return type annotations. You can enable them or disable them simply by pressing from the Alt-Enter menu. Just press Alt. So you can enable them by pressing. OK, so anyway, you can enable them in the settings. They are in editor, general appearance. Sorry. It's under. Yeah, I'm not showing it, yeah. Show parameter names, hints, configure. And here you can see all the options that are available for Kotlin, like you can show local variable type hints, function return types hints, parameter type hints, and so on. Okay, so we have a bunch of refactoring supported. So a recent one that we added is inline method. So for example, we have this like as-min string method. It's used in a bunch of places. And we can just inline it so that like this, or I don't know, like we'll inline this, get readable hours. So it shows that it has 3 occurrences, and now it will inline this method, and all of these occurrences will be replaced with the expression that actually was in the method. And of course, this works for more complicated stuff as well, which is not just a single expression. And the next feature I'll try to show another nice feature, which is somewhat involved, so I hope the demo runs fine. So the feature is called data flow to this. So we have this method which we previously saw that performs a search. And we may get interested, like, where does the query string come from? How does the data flow through the application? And we can use this analyze data flow to here action. Tell it to analyze the whole app. And this actually traverses the call hierarchy of the program where this method is involved. And so you see that it's coming from here, and then it's coming from here, and then it's coming from here. And in the end, we are in this onSearch query changed function. So this has been supported in Java for quite a while. We recently added support in Kotlin as well. And this is a feature which comes up sometimes where you just get a value, you see a value in the debugger, it must not be there, there is no way for it to be there, but it actually is. So this helps you understand where it comes from. So that's what I wanted to show in terms of IDE features. Now let's do the somewhat more tricky stuff and see if I have internet access. And let me switch to let me do the phone trick again. So the thing that I want to talk about is support for static code analysis. So people are asking us about static code analysis tools. So they want tools that enforce a consistent code style and code quality in their projects. And probably the most established tool in this area is Sonar. And we do want to provide plugins for Sonar, but at this time they are not available. So there is a third-party plugin based on KTlint, which is also a third-party static analysis tool that does a fairly decent job. We want to provide an official one. It's not there. What is there now is support on TeamCity. So TeamCity is a continuous integration server that we build. And one of the features it offers, it actually embeds an IntelliJ instance, and it supports running IntelliJ inspections just inside it. And because it's CCI server, they run automatically on every build. You can fail the build when the number of detected problems exceeds some threshold. You can configure which inspections to run and which should not be run. And this is still very slow. So I guess you're going to have to take my word for this. We want to build Sonar plugins, but they are not there yet. And finally, the last thing that I wanted to mention is what we are doing in other areas. So in terms of not IDE, but build tools. With build tools, there's actually one goal that we have, and which I guess everyone else has. That's the build has to be fast, and it has to get out of your way. And that's all you care about. And in order to support that, we are doing many things besides just optimizing the compiler, which we also do. We want to support incremental compilation for all targets that we have. So we've had JVM incremental compilation for quite a while now. We are almost done implementing JavaScript incremental compilation, or entirely done, should I say, and this will be released as part of Kotlin 1.6. And the next thing is that we want to support incremental compilation for the remaining platforms, so for common code and multi-platform projects, incremental annotation processing, and native compilation, and so on. And in order to enable this, we are also working together with Gradle to enable support for new Gradle features in our tools. So the build cache, incremental compilation, we are going to integrate with all of that and try to deliver as efficient experience as we can. So did TeamCity load? TeamCity did not load. OK, too bad. So that concludes my presentation. You are welcome to ask questions. You are welcome to come by the JetBrains booth or the office hours booth to ask us more about all the stuff that we are doing. And thank you for your attention.